Yes, yes.
Yes, ma'am.
Okay, all right. Okay, Nalini, I'll take it forward.
Thank you, Pratibha.
Hello,
Yeah, hi.
Anubhav. Good morning.
Good morning.
Yeah, please introduce yourself.
Yeah, myself Anubhav, I'm working with Philips over 3.9 years, where I am experienced in like automating, maintaining, and like improving deployment pipelines and Kubernetes operation and cloud infrastructure. And if you come to my like day-to-day like activity, so first activity is like monitoring and alert handling. So we have to monitor the pod health, infrastructure usage, and like service uptime. We are using Prometheus, Grafana, and for CI/CD basically we are using Jenkins. So I have to like create and maintain like a multi-one Jenkins pipeline with artifact promotion. We integrate these things with like SonarQube for code quality check, and we are using Trivy for vulnerability checks. And our pipeline is fully parameterized for like dev queue and pod environment. We promotion this artifact. We are using this ECS cluster. Then for Kubernetes section, so we are using EKS cluster. So we deploy 10 plus microservices, like different microservices in AWS EKS. And I have to like maintain and like write this Kubernetes manifest file, like deployment services and ingress, config map secrets. Then come to like incident responding, so we are using service max and Jira ticket. So I have to like update those tickets as well. And for automation we are using Ansible, so we have to write Ansible rules. And also we are using bash scripting and shell scripting. For cloud basically we are using AWS, so I have to work with AWS different provisioning, like AWS resources like EKS cluster, EC2, S3, RDS, IAM role. And also I have to write Terraform scripts for automate this EKS cluster, VPC setups, VPC configuration, that kind of things.
Okay. So, what is your regular activities on Python?
Python basically not much regular. So basically we have to write Python script. Basically last time I wrote one Python script for like this lambda function with this is basically cost optimization. So I wrote this Python script for that. And also means one time I have to wrote this sales scripting. So basically this sales scripting for restart this different microservices pods. So I wrote this kind of scripts, Python and sales scripting. So
Okay,
should I
it's not like a hands-on experience on Python, is it?
hands-on basically? So this script I have to wrote. Like, should I explain this what about the scripts and all?
No, my only intention is to understand it in Python, like how familiar are you, like I mean, on basically on the um, development side, especially on the programming side.
Programming basically like Python programming. I'm not like aware of this. Like so, this I am fully in DevOps. So I am writing basically scripts, Python small script like Boto 3, this kind of automation script I have right. I know about these things about Python.
Got it. But it's not like a end-to-end programming sort of
Yes.
work,
Hmm.
right?
Hmm.
Okay, okay. But your major work is on DevOps side, right?
Yes. The DevOps only.
Okay. Okay. So in DevOps, like what is your major area? Is it DevSecOps or I mean in your regular activities?
Regular activities which I explained basically. So a CI/CD pipeline basically, which is like we are maintaining this DevSecOps, and also like this EKS side means troubleshooting side, and also like writing this manifest file and all those things.
Okay. Manifest file. Okay. So do you have any experience in OpenShift clusters, Sabino?
Uh, OpenShift, no. Basically, we are using EKS cluster.
Okay, okay. So in the EKS, is it like you were administrating the EKS or how is it like how you exactly manage? Is it like you are helping application teams to onboard into EKS cluster or you are taking care of Kubernetes upgradations or migration, something like that?
Kubernetes migration application is done by our seniors and all those seniors basically. So we are basically provisioning this EKS cluster. So we are we are deploying this EKS cluster by a Terraform script basically. So by that Terraform script means our EKS cluster going to be set up. So, and after that we have to like create the manifest file, services, ingress and all those files, and we integrate these things with our GitHub, basically GitHubs. Then from there means we can deployment our application in the EKS cluster. And
Okay, all right.
this cluster fully monitored by this Prometheus, Grafana, EFK stacks and Jaeger basically. So you are using this kind of tools to like monitor these EKS clusters.
Okay, okay. So, okay. So now I totally understand that you are basically provisioning EKS clusters for the application teams, and so are you also taking care of Prometheus, Grafana integrations in the clusters as well?
Yeah, integration things we are
Those
doing.
integrate.
We are creating means set up this
Okay,
Prometheus, Grafana, EFK stacks, all those things. Jaeger.
okay, okay. All right. So, Anubhav, let me understand more on the EKS provisioning part, right? So, when you are creating the EKS cluster, right, what are the primary things that you consider? And I really need the step-by-step focus areas first. You will, when you are provisioning in the cluster, maybe you can share your screen and, give me some steps over there, and, give me some the kubectl commands that you operate. Okay.
Okay.
And what are the various components that you look for? Yeah. Please go ahead.
Okay, so first means I'm explaining this things about this EKS cluster. So basically, we provide this EKS cluster full like high availability and secure and means basically this kind of things means you have to secure and all those things. So for that means how we set up for high availability. So first like basically, so we have like we are using AWS application load balancer. Okay. Then after that,
Okay.
what
So
happened?
first step is AWS application load balancer. So you are going to provision first this one.
Okay, means okay. I'm from beginning only. I'm just starting. So first means
Yeah, yeah,
step by
yeah.
step. So my planning of the cluster basically. So we are using different microservices. So and microservices should be like it will be highly available. So for that we are using multi availability zone. Okay, multiple availability zone. Okay, so we will do these things first. So we are means creating the means we are this is available fully multiple availability zone. So after that we have to create like create this multi availability zone EKS cluster. So for that means what I will do, I will first these things with like VPC. Okay, so VPC I have to create one pipe means like private and public subnets across like three availability zone. Okay, and basically we are using this EKS cluster. So for that one things we need to do, which is like subnet tagging. Because of subnet tagging, so EKS cluster will be understand. Okay, so for that means we have to do this subnet tagging. So we have to give one tag like kubernetes.io something like role and something tag we have to use. Okay, this is the step 2. And step 3 like we have to deploy microservices, and microservices should be like with high availability zone. So for that what we will do means we will deploy these things with like 3 plus like replicas. Okay, and this replica should be like separate availability zone. So how I can achieve these things? So in Kubernetes we have one we have one concept which is called pod affinity. So pod affinity we can use to like set up these things with different availability zone. Okay, okay, so this will be done. Then after that what I will do, I will like creating all manifest file like deployment services, config map secrets, and if you want like high availability, so I'm talking about, so we can set up this HP as well. Okay, this kind of things I will be set up over there. Okay, I'll create this YML file. Okay, so these things is done. Then step 4, what we will do, we'll set up ingress. Basically I am talking before only. So ingress basically what happens, so we are using application load balancer ingress. So first I will install this application load balance controller by Helm or something, so I can add these things. Okay, then I have to create one ingress file. Okay, that ingress file I have to set up this ingress file by the path based routing. Okay, this is for the like this is for application load balancer ingress side. Okay, ingress side is done. Then After next steps what we'll do, I'll
Can you write it down, please, Anubhav?
okay,
Please
which
also write it down. One you said VPC, and then you mentioned subnets,
okay,
right?
okay, from beginning only I'm writing. So first I'll do VPC, okay, and VPC should be like multiple abilities zone, okay.
Multiple availability zones. Okay.
Then next steps two what, yeah, I have to create this mm, multi available zone EKS cluster. So for that I will do some like VPC, like private public subnet, okay, and that should be like
Mm-hmm.
almost like three availabilities, man. This thing is done, okay. Then
Okay.
this step, second step is done. Third step what will do, third step I'll create like microservices. I have to deploy microservices, and microservice will be like high available, highly
Yeah.
highly available, okay. So for that what I will do means I have to like set up these things, set up to achieve I can use this pod affinity, pod affinity, pod affinity, and after that I will do like I have to write like different one means microservice manifest file, like deployment services config map, this kind of things, okay. This three is done. Then fourth step is coming. Fourth steps like we have to set up ingress, application load balancer. So for I have to install balancer controller. Then I have to create ingress.yml file. Okay. Then yeah, ingress.yml file I have to create. This thing is done. Then yeah, fifth step what I'll do. I have to configure. I have to configure. I have to configure auto scaling. So means AWS EKS cluster.
Anubhav, I have a question here. So when you say configure auto scaling, are you doing through the Terraform, or is
Yeah.
it like you are going?
So
Okay, you are logging into AWS and then you are just creating through the manual steps.
okay, so basically for these things means auto scaling. So auto scaling we can achieve by this HP, okay, horizontal pod auto scaling. So that we can create, okay, by auto scaling. And also means AWS EKS provide our cluster auto scaler. So that we can use, means cluster we can install this cluster auto scaler as well. Okay, by that way we can achieve these things. Other things means I read some blog and means other YouTube videos that we can also use carpenter for achieve this auto scaling order. I'm not means about this, we are not using carpenter over here, but I'm learning these things. We can use carpenter as well, basically.
So when you say carpenter, right? So are you going to create carpenter into a separate controller altogether instead of
For
how
carpenter,
exactly you? Mhm.
yeah, for carpenter basically means I am not about these things fully. So basically we have to create one YML file or something like that, then we can achieve this means carpenter things. We have to install this carpenter by Helm repo or something, means I am not aware of this. I means heard from someone.
Okay. So
But
using a Helm repo, let's say you install Carpenter. So when you install Carpenter in your cluster, right? How it is running? Is it running in a separate namespace under separate pod, or I mean, how the Carpenter controls the entire Kubernetes? Because we are heavily using Carpenter here, so I just want to understand what your thoughts on Carpenter. What is your understanding on Carpenter?
Miss Carpenter is working like if we install this Carpenter as a like Helm repo. So basically for okay, so by Helm repo if you install Carpenter, so maybe means it will create one like different namespace means and that namespace means we have be provisionized like something Like that way means I'm not sure about that.
Okay, that's fine. That's fine.
Cloud
Okay.
painting.
Yeah, let's go with this flow. You are telling configuring auto scaling into AWS EKS.
It- or cluster autoscaler as well. HPA you can say we have to, HPA also will come over here. What we'll do? Yeah, for like security section means this is done. Security. Security section what we'll do, yeah, for section IAM role should become like we have to create IAM role for like service account. I create IAM policy over there. Okay, then I have to like set up yeah, so IAM role it will become first, then other things we can do. IAM role for provisioning. Mm, or can you, if you want more security, then network policy you can do.
Okay, so you are creating a IAM role policy here, right? So that role where you will integrate.
So I am role. Hmm.
Yeah, please go ahead.
Yeah. So for I am role policy, you can create basically for like provisioning the like means if you have pod microservice cluster, so you can provision it like we can attach one policy over there means ARN policy, and if you want any kind of access something like S3 bucket or something, so for that means we can use I am role. Okay, and for like network policy basically we can create like a you can install Calico. Okay, after that you can set up your network policy that like our backend port wanted to communicate with front end port, so that network policy you can give if you want more security aspects from here. So these two things will do for the security, and if you want more security.
You said Kaniko, right? So what is Kaniko?
Calico basically, see, it's a one kind of network. Network means your if you wanted to means EKS cluster, if you wanted to means basically Calico basically achieve like all the networking things. It will be handling this Calico. So for Calico, for that you have to install Calico in your EKS cluster by means kubectl apply command -f. Then means you can install this Calico, and after installation this Calico you can achieve this means network policy. You can create a YML file, and that YML file basically for this YML file kind should be network policy, and that networks policy you have to like give the different permission. Like I want my front end basically means my backend wanted to connect with front end ports, so I can give this rule over there. So how this rule will be means identify your port basically, so it will be achieved by our means selector, port selector. So port selector you can means port selector will be there, so that port selector means tag you have to use over there in your network means network policy.
Okay. Yeah.
And means more security if you want to use, you can use like secure your basically all your secrets and all those things. We have Kubernetes secrets as well. In our organization we are using Kubernetes secrets base 64, but if you want more security you can use this HashiCorp vault as well. Okay.
Okay.
Okay, so after the security this is done. Security, what next things we can do? After next things we can set up this policy. Okay, for security also done. Okay. After what? After means for like monitoring and setup we can have to do. For monitoring you can use this Prometheus.
Okay. How will you integrate Prometheus or Grafana into Kubernetes cluster?
So you can integrate this Prometheus Grafana by means we have like Helm repo. So by using Helm repo, install this Prometheus and Grafana, and basically these things will be like this Prometheus basically is one kind of data source, and Grafana is a help for the dashboards, and this will be basically for metrics purposes. So any means basically CPU utilization, memory, all those things, it will be handled by this Prometheus and Grafana. Okay, Like we are using EFK stacks, so means for logging purpose only, means and that things means EFK stacks. So basically EFK stacks, what happened, so means if developer instruments some custom logging setup in their application, so that would be scraped by our things, and we can see this dashboard by the Kibana. Okay. And Elasticsearch, here Elasticsearch, what happen, it's one kind of like database. So it will be like take it will be take your all the means store all the logging things to your Kibana, sorry, to Elasticsearch, and Kibana will be take it from there. And for tracing, basically we are using tracing from OpenTelemetry. So OpenTelemetry means developer should be instrument this OpenTelemetry in their application, and by Jaeger, by Jaeger you can check the UI, and that UI you can see means basically how much half data will take, like different microservices is there. So one request come to another, one request come one microservice to another microservice, so how much time it will be taking, so that will be means we can instrument from there, like this Jaeger UI. Should I explain like full setup, like how basically this monitoring things happen?
I'm more interested, like, how you are integrating this Prometheus Grafana, like you mentioned, right? So you are getting the CloudWatch logs and putting that into the Elasticsearch, and from there. How would you integrate using Terraform? Like, is it, I mean, as in your current role, are you doing through manually, or is it like you're doing through the Terraform?
uh, Terraform basically you are using for like creating the like infrastructure, AWS infrastructure, like EKS cluster creation, and like small services creation in our this means AWS. So for that purpose we are using Terraform. I know about Terraform, all those things like custom modules, and like different modules and workloads, this kind of things I know.
Okay. But Prometheus Grafana is something like you are manually configuring in your cluster, is
Yes.
it?
By
Okay, got. Okay, yeah, please go ahead. That's fine. That's fine. You don't need to explain deeply. That's fine.
Okay.
Monitoring. Okay, after that.
So yeah, that will be like after like monitoring, so that will be like full setup means by this EKS cluster, like high availability, security, and like uh,
Okay. High availability, security. Okay. And let's say now the next step would be your application needs to be deployed into EKS cluster. And how do you ensure your application is running fine? If it is, connected with the right ports? Can we also
okay.
have something similar? Yeah.
Okay, so for like I mean, see, this is the setup of our EKS cluster. Okay, and for deploy means our application to our EKS cluster. For that, we are using this CI/CD pipeline basically. Okay, so now and for that, like our monitoring setup, all those things done. Now means basically what happened. So something happened means our application is not running. So for that means we can use different like kubectl command, or first you can check the dashboard and all those things. After that you can log into the server and EKS cluster, and then you can check by first things what we need to check, we need to check the events log. So for that we have kubectl describe command. So by using kubectl describe command, I can check like whatever like means events log is there or not. Okay, so after that means event log is done, then means we can check the logs basically. So like you have deployment, okay, that logs you need to check. So kubectl log command is there. So by using kubectl log command, I can check like means whatever logs is there or not. And means you're talking about like code and all those things, so you can describe your ingress. So if you set up your ingress over there, you can describe your ingress. So kubectl describe your ingress, so there you can check like means endpoint is properly or not, means this connectivity is properly or not. Or if you want to go more deeper, so you can use kubectl exec hyphen it command and go inside this a container, and you can check like telnet command or ines lookup command. By using this command you can check, means I know about these things, means I also done some like this kind of like troubleshootings also in my current project as well.
Yeah, okay, all right. Okay, so I have some deep dive, to happen on the pod affinity and the manifest files that you were talking about, right? In the third point. So deploying microservices with the high availability, right? So can you talk about what is a manifest file in Kubernetes world?
A manifest file basically means I'm talking about this manifest file basically for like deployment, like ingress, this kind of files basically. So this is the manifest file. And how can I achieve this pod affinity? So pod affinity I can achieve by so first you have to like tainted your node first, okay, and that tainted node, and that by using this tainted node you can use one tag, okay, and that tag you have to use your deployment, so then you can achieve this pod affinity.
Okay, let's say I want to only have two nodes, okay, in
Okay.
my Kubernetes cluster for this particular application to run. Where exactly I need to define that information?
Come again.
I want to operate my application only in two nodes.
Mm-hmm.
Okay, so I want to set up that into the cluster configuration. So where I have to put that into the, I mean, in all the steps that you have defined, right? So which step is responsible to set up, the number of nodes and the number of pods, something like that?
Number of node, number of pod. Mm,
Let's say I want to have my application, my microservice running only in two nodes. Okay, not more than that. Even if there is a high load also, I don't want to provision new node for it.
okay, we don't want to. So for that means you can okay, only two nodes. Okay, I want only two nodes. So for that nice means when I will create the node group, in that section you can specify your node number is two, and no minimum node is two, maximum node two. So it will be like a desired capacity and like a minimum and maximum capacity. It will make two only. So that section you can do like when creating the node group.
Yeah, right. Anubhav, I totally understand when you are creating a manually cluster deployments, you can give that a static number. Let's say, later part,
Okay, you are talking
I
about the
thought like, okay,
replica sets like
huh,
means your deployment or OML file. So in the
correct.
replicas, like we can set up these replicas. How like
Correct. Yeah. That is what. Like
okay,
say
okay.
tomorrow I want to have it as a four nodes, right? So where should I, as an application owner, where should I define all this information so that it is automatically reflect into my Kubernetes cluster hosting platform?
Deployment or OML file means if you wanted to make more pod, then you can set up over there like replicas 4.
Got. Yeah, that's what I'm looking for.
Okay.
Okay. Okay. So deployment.yaml file, and you have the services.yaml file where you need to define what are all the number of node replica sets that you want, right? So yeah. Okay. And coming to let's say if there is some issue happened in the Kubernetes cluster, somehow I'm unable to auto scale my nodes. What would be your troubleshooting steps over there?
Okay. So yeah, got it. So this is happening basically. See, so when you do the these things deployment of OML file, that section, what we'll do, we give the like numbers, like how much CPU I want and how much memory sticks I and want. Okay, that section means you have to means if it's like a full means our like all memories is exhaust. Okay, so our cluster autoscaler is not able to spin up one new node. So this is the issue we can got from there. So how I check? So basically I can basically there is one namespace, okay, this cube system namespace, okay, and there means in cube system namespace we have like means cluster autoscaler. That things I have to check means why our application means auto scaling group is failing. Okay, you have command like kubectl -n cube system, then you can check logs, okay, this cluster autoscaler, it'll, you can get different error. Basically this error I already means troubleshoot this kind of things, means it will show you like something like means fail auto scaling, okay, access denied, something like that. Also means your max node is reached, it will be show over there, your max node is need, node group is not scaled, light up like of means error you can get from there. Okay, so then I understand, okay, means our auto scaling is auto scaling group is not able to uh, working properly. Basically our maximum capacity is gone. So then what I'll do, I for like resolve these things, what I can do, I can give more memory over there, okay, and then I can spin up the our EKS cluster. So by that way you can like means resolve this kind of issue.
Okay. So may I know something more about the cube system namespace and what are the different types of namespace that we can have, purpose of each namespace?
Like default namespace in EKS cluster.
Yeah. I mean, what is a namespace and what sort of namespaces that we can have in EKS cluster?
Okay, so basically a cube system namespace. So basically it's a like default namespace where like this kind of like
Yeah.
auto scaling and all those things is there. Other namespace like mm, okay, cube system namespace. In this namespace is for that, and other namespace what we have.
Let's say I want to deploy my application, right? Can I deploy my application in cube system namespace?
Mm,
What is the best practice?
base practice for that, like you have to create one like new namespace, kubectl create ns, then in that namespace, like if you wanted to deploy in a dev, basically, so you can create separate dev namespace and prod qs. So this is the best practice to create the new namespace and deploy your application over there.
Okay, so where should I define all this namespaces information in my application configuration?
Application
In
means
your,
deploy,
yeah, in your all these steps.
come again,
Let's
like
say, let's say for dev environment, I want to deploy it in dev namespace, QA environment, QA. How I can do this automatically?
automatically for that, like when you do this kubectl hyphen apply, so that time you can specify hyphen in the namespace, or else inside your deployment
But
file.
again, you are telling anything, everything through the manual way,
Okay, okay.
Anubhav. What I'm really looking at is the automation. Through the automation, how can I ensure, let's say I have committed a change in my application that needs to be deployed in dev environment and that's supposed to be deployed in the dev namespace. Where should I define all these things so that it automatically takes care of all the deployments? I really need to, think through automation way
Okay,
and
okay.
explain me.
Okay, that is like kubectl command. Okay, for automatically what I can do, in automation section. So means yeah, so see, if you create one deployment file, okay, so deployment.yml file,
Mm-hmm.
.yml file. So this deployment is yml file for the dev. Okay, I'm saying this is for dev. So in your deployment.yml file, we have like metadata section. In that metadata section, you can
Mm-hmm.
like specify this namespace. Um, namespace, then we can give this dev, so it will be deploy your dev namespace. So in the deployment.yml file you can do that.
Yeah. Yeah, that's what I'm looking for. Awesome. Okay. Now let's talk about the namespaces. So what is the purpose of namespace?
So namespace, basically it will be like one isolated environment you will create for like for Kubernetes. So if you create one dev namespace, so everything will be isolated over there only. And if you create one prod namespace, it will be isolated over there. So it will be identical for each other.
Okay. Now let's talk about the Prometheus Grafana, right? Even let's say I want to deploy, I want to integrate with the Prometheus. So which namespace I can integrate this Prometheus?
For basically for we are using it will create one monitoring namespace, okay, and your all those things will be deployment over there, like Prometheus, Grafana, all those things will be Cube State
Okay.
Proxy
Then
and
it
all those
means
things.
it's like you're isolating the monitoring into a separate namespace altogether, is it? Okay. So how all these namespaces will be controlled in Kubernetes cluster?
We have controller, right? So in our Kubernetes, if you see the Kubernetes architecture, we have controller. So we have different controller is there, like namespace controller. You have who namespace, basically it will manage all the namespace. Then deployment controller, so it will be managed by the controller, for my understanding.
Okay. How do a controller knows, a namespace should operate in particular nodes or these many pods? Let's say if one pod is going down, it automatically spin up another pod. How does a controller knows all these things?
So these all those things means basically, for my understanding, I am thinking, I don't know if this is right or wrong. So we have etcd
Okay.
database. Okay, so all the information going to be stored our etcd database. Okay, and that controller connect means communicate with this etcd database. Okay, and it will be get means all those information from there. For my understanding, basically. I
Okay.
don't
All
know.
right. Okay. Fine. Let's say okay, so you said it is going to get that into the ETC2 database. Okay, fine. Sure. I think I'm done with
Oh,
my interview, Anubhav. Let me know if you have any questions.
yeah, so basically, so I have to work like means different cloud, or like it will be only for like AWS or in particular.
It is particular to
Okay,
AWS,
okay.
but this basically we are not touching anything manually here, Anubhav. So based on my interview discussion with you, most of the times that you are bringing the manual processes in between, right? But we generally do not do. We never touch the Kubernetes cluster. Everything through programmatically.
Okay, okay.
So all the Kubernetes clusters, administration, upgradations, patch management, the pod, spinning up the pods, draining the pods, everything through Terraform.
Okay, Terraform.
You know, yeah. So that's the only difference, that the way that your current work is different from what we are doing.
Okay, okay.
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 Any other questions, Anubhav?
Yeah, no, no, no.
Okay. Cool then. Thanks, Anubhav, for your time. We'll get back to you. Okay.
Yeah, sure, sure.
Yeah. Thank you.